It might
So
be.
It might be 10x. So 10 was the number that I was actually thinking of. I spend about maybe roughly a fifth of the time coding now that is it compared to 6 months ago, but I'm producing more than 5x the code and I feel more than 5x productive. And so it frees me up to do a lot of other interesting things like, I think you can spend a lot more time on the inputs to an engineering problem. Like you can think about how it should be designed, how we should architect this, how it will fit into other pieces of the system. Overall, 6 months ago, I was writing all my code by hand, and now I haven't written any code in maybe like 2 months.
all right, we
And we are
are
live.
live. We are live with Steve Coffey, who is a member of technical staff at OpenAI. He works on developer APIs, including the Responses API, which we'll talk about today on MTS. Steve, welcome.
Thank you so much for having me.
Absolutely. So for the audience, tell us, what is the Responses API?
Yeah, so the Responses API, we kind of think of it as it was originally designed as sort of like our agentic primitive. We kind of designed it as an evolution of the previous generation API, which was chat completions, if anybody's familiar with that, as a
Yes.
way for developers to take advantage of new capabilities of the model. At that time, it was reasoning, but we really wanted the Responses API to kind of have like a brand new design that would kind of allow it to do agentic things on its own. So, it itself is kind of a mini agentic harness. A lot of times we think of Codex as being an agentic harness, but before that, even the Responses API could do some of these agentic things on its own. Could had the ability to use something like a file search tool where it could go off and search some files that you have previously uploaded and then come back with you with a response or do something and search the web, sort of these like mini agentic interactions. And now it's kind of the base layer upon which all of our agentic products are built. So Codex, a lot of the ChatGPT for Work stuff, which is kind of a layer on top of Codex.
Mhm.
It's sort of this like fundamental base layer that developers and our own products use to build these highly agentic experiences.
Mm. I actually remember way back in the day in like 2021 using
Yeah.
the OpenAI API back then, and it
Yeah.
was much, much simpler than it is
Yeah.
now. So like
Yeah.
what are some of the most important changes that have been made from then to now?
Yeah. So the kind of first version of our API was the completions API. And this was super simple, right? You just have a bunch of text. You'd say, hello, my name is, and then you give it to the API and it would just finish your sentence. It was almost like a sentence finisher API. And this was sort of like predates the chat style models. So if you remember DaVinci 003 from way
Yes.
back when, this was like our
That was my
completions
go. That was
model.
my boy.
Yeah, it was honestly pretty good to the time. That's what originally got me really into. This is before I worked at OpenAI, but this was originally the thing that blew my mind. I was like, wow, like this is we've we've solved it, right? It seems crazy, compared to the models we have today. But those early APIs were really just around kind of like completing individual sentences or completing phrases, and people would try to use them to build these chat interactions. They would few shot the model to say, okay, me, I say this, model, you say this, and then they would give the new user input, and then they would kind of expect the model to follow the pattern, try to parse that out. And then we got GPT 3.5 Turbo, which was the first chat model. This was the model that ChatGPT launched with back in 2022. And we needed a kind of a new evolution of APIs to be able to serve that kind of like more, back and forth user assistant type interaction. And so that kind of gave rise to the chat completions API, which had a bit more structure around it. So you could kind of do these back and forth interactions a bit more easily. And then we got, tool use in the API
Mhm.
and especially reasoning. And that kind of led us to, think holistically about sort of what is the developer experience paradigm that we really want to deliver. And that included a lot of things that chat completions just fundamentally wasn't designed to do. We had no way for you to recycle chain of thought back to us. And so if you tried to use reasoning models in the chat completions API, the model would, forget all of its reasoning. You wouldn't be able to pass it back. And so it would start over reasoning again from the last point that it had seen. And kind of is a bad experience and didn't really deliver sort of the top tier of intelligence that we kind of want to give to our users. And so
Mhm.
that's kind of like how the Responses API was born. That's what we have today. And again, a lot of our products are built on this.
Awesome. So, how do you guys think about API efficiency at OpenAI? How do you measure it? How do you make the API more efficient?
Yeah, this is something I'm personally super obsessed with is making
Mhm.
our API as fast as possible. It kind of comes at a bunch of different layers, right? We have a whole team that just works on inference to make our engines and our GPUs that are serving the model, that whole stack, as efficient as possible. And our job on the API is to basically make there be almost no time taken at that API layer that's above what is spent at the GPU layer. So you can kind of imagine this mental model of API performance as being, we get a bunch of tokens or we get a bunch of text in the form of, maybe it's a bunch of text or images or whatever. We have to do some stuff to like translate that into tokens, and then we send all those tokens to the engine, to the GPUs, and then we get a stream of tokens back, and then we have to turn those things back into text and send them back to you as a developer. So all that stuff that happens basically between when we send before we send the tokens to the engine, and then as the tokens are coming back, it's all stuff that we have to make super efficient. So we've done a handful of things to make our API really, really fast and efficient. The number one is we have just kind of burned down a lot of the performance kind of bottlenecks in our Python stack. Traditionally, OpenAI has been pretty much purely a Python shop. A lot of our research code is in Python, and that has the tendency to kind of bleed across the whole code base. And so we are just spending a lot of time optimizing that. The one really cool thing we've done that Codex actually was sort of a big driver of is build sort of a WebSocket integration into the API. And so the reason we did that is a couple of reasons. The biggest one is that when you use our APIs, you're often round tripping all of the context, the full conversation every time you want to get one new incremental output. And what that forces us to do is, reprocess all of that conversation data again and again and again, even though there's only a little bit that's changed from request to request. So with a WebSocket, what this allows you to do is you can keep the connection open, you can tokenize, you can process all of that stuff just one time, and then the Codex now, and anybody who uses our WebSocket API can just send the new messages over that same connection, and then we'll have to do a little bit of marginal processing in order to be able to give you back some tokens of your own. So this has done a ton to speed up, these really long kind of like agentic rollouts. So these Codex style integrations where it's calling a bunch of tools and then finally giving you an answer back. This was kind of like the single biggest change we've made, and then we're kind of doing a number of rewrites across the stack, rewriting Python to Rust in places where can't really squeeze any more performance out. So it's something the team like totally obsesses over, and places where we've already made a lot of strides and expect to make a lot of strides in the next couple of months.
Yeah.
Right. So I imagine that you are using OpenAI models and Codex like all the time internally for developing.
Yeah.
How helpful are they now, and how much more helpful have they become over time? Like, if you had to come up with a number for like how much more productive you think you are because of current coding models, I imagine it's not 10x, but it's definitely more than one.
It might be.
It might be 10x. So 10 was the number that I was actually thinking of. The thing I always say is that I spend maybe roughly a fifth of the time coding now that is compared to 6 months ago, but I'm producing more than 5x the code, and I feel more than 5x productive. And so it frees me up to do a lot of other interesting things like, I think you can spend a lot more time on the inputs to an engineering problem. Like you can think about how it should be designed, how we should architect this, how it will fit into other pieces of the system. And being able to apply a lot of that critical thinking before you sort of hand a problem over to Codex to just implement actually goes a long way, because you can get it kind of like right on the first time, and you're not actually spending all that, those cycles otherwise that you'd kind of be spending like coding instead of just kind of thinking about the inputs. So that's a big thing. I think I have a lot more trust in the models now when I ask it to, give it a well-scoped problem to go work on. I have a lot more trust that it's going to get done in a way that I'm going to be comfortable with. So that's a lot better. But I mean, overall, 6 months ago, I was writing all my code by hand, and now I haven't written any code in maybe like 2 months. So
Yeah, I guess on that topic, what do you see as like the difference from people that are like sort of coding native, they sort of like formally learned how to code, versus people who are just like the vibe coding class? Like, how do you see? Do you see that there's
class?
Yeah. Because I got into coding like very much when like LLMs were already beginning to be a thing, even if they weren't that good. So how do you see, like, are there actual performance differences in people who are like very native to they actually learned how to code properly?
I think like Codex and a lot of the coding tools are kind of like great equalizers in some ways. Like they kind of you can kind of expect that the same code is going to be kind of produced by everybody. I think that, understanding the inputs really goes a long way. So if you kind of understand, like, if you've been working in software for a while and you have like a general understanding of like system architecture and, how things should be built. And this matters, maybe more if you're working kind of like at scale or at a big company. It matters a lot less if you're working on, if you're a solo founder or building something 0 to 1 and kind of going from there. But I think it's kind of been really magical in just being able to see, things being able to be built by people, no matter how much experience they have with software. Like, that's a really cool thing. Like, people are coming to me and showing me their side projects and things they're working on. I think that's like so cool. And I think that like that sort of tale of, models will eventually get good enough where they can kind of like solve these input problems and, thinking about the architecture more holistically. And I think we're just not quite there yet. And so eventually it will be super equalized. I'm not sure if that's a good answer to your question or not, but that's kind of like how
No. In like the GitHub Copilot
Back
era.
in my day.
Back in my day, in like
Yeah.
2021, when all we had was like half decent like line completion.
Yeah.
And just like the state
Yeah.
of coding models today is just like incredible. The amount of stuff I'm able to do is incredible.
Yeah.
Even my dad, who is a smart guy but doesn't know how to code, is like making an actual like B2B SaaS startup with
love
Codex.
That's amazing.
Yeah, totally. So another question I wanted to ask you is like, how do you see the price sensitivity of people in the real world to, let's say, like differences in API pricings for different models?
Thinking specifically about, well, I guess maybe my kind of prior here is that I think we really try, at least at OpenAI, to kind of build models that kind of like fall along all points of the sort of like price and performance curve. Ideally we have like a really great model that's so tiny that we can run it at a very, kind of a fraction of the cost or very low cost. But bigger models do tend to perform better, especially on some of these like hard problems that require a lot of intelligence. And so, we try to train smaller models that are distilled from our bigger models to be able to kind of like provide really good intelligence. But we still have those kind of like bigger, more expensive models that you can reach for when the smaller ones like aren't quite working out.
Yeah. I love that philosophy. Another question is like, during a long agent run, what do you see right now versus what do you predict in the future? Is like, the time bottleneck, like where does the time actually go? Like, is it the actual tool call? Is it reconstructing the context, inference? What is it right now?
Yeah. It's kind of interesting. We have like, for my POV at least, I think a lot of the time is kind of spent on tool calls. We have some model. I don't know if you all have tried GPT 5.3 Spark at any point. This was our GPT, Codex model that was running on Cerebrus. So super fast inference. And it was really awesome if you're just asking it to go and write a whole bunch of code in one shot and it takes, 2 seconds, then it's done. If you're asking it to do something where it maybe has to look at Slack or look at Notion or search the web, these are the bottlenecks where it's like those MCPs are a little bit slow and it takes a few minutes. And so no matter how fast the tokens are coming out, like that kind of becomes the bottleneck. I think like we think about bottlenecks in different sizes, right? Like tool calls being one kind of like big example. We think about them down to the micro level, like in our API, kind of getting back to this efficiency thing that I was talking about a minute ago. We kind of look at every single part of the stack and try to figure out, are we losing some time in the safety stack? Are we losing some time, to the Python async IO loop, or we don't have our work perfectly overlapped so that it can kind of, get it work the most efficiently. And so we kind of like look at all parts of the stack, but I think like if you're an average Codex user, kind of like looking at your own rollouts, probably what you'll see most of the time is the tool calls are taking up the most of the time. And we're trying to find ways, creative ways to reduce the number of tool calls that the model has to do in order to give you a good answer, or make the tool calls it has to do a little bit faster and things like that.
Yeah. Well, that's a great place to wrap. Thank you so much.
Cool. Awesome.
Steve,
Thanks so much
for coming on MTS.
Great.
Absolutely.
Yes. Thanks so much for setup mocking us.
Yeah. We will get there soon.
Awesome.
Yeah.
All right.
Thanks so much, Steve.
We'll be right back for with MTS.
Thanks.
We'll continue monitoring right after this message from our sponsors. Scale your startup on Neon, the Postgres backend for apps and agents built by Databricks. Neon.com/MTS.
11 Labs, AI that communicates at human level across every channel and modality. 11labs.io/MTS.
Special thanks to our sponsor Kong. Kong, the AI connectivity platform. Connect APIs, LLMs, agents, and systems with serious security and governance. Try it at konghq.com. Thanks to Blitzy, autonomous software development for enterprise codebases. Ship 5 times faster at blitzy.com.
Let me tell you about Merge. OpenAI, Dropbox, and Ramp use Merge to get AI to production faster. Merge.dev/MTS. Quick word from AdQuick. Make your brand a billboard. Out-of-home advertising as easy to scale as digital. AdQuick.com.
Thanks to our sponsor, Macroscope, AI codebase understanding for engineering leaders. Try it out at macroscope.com/MTS.
If you think about what the right AGI pilled harness is, it
Yeah.
should be the model writes code and the code does everything, instead of giving the model a laundry list of tools that it should be working on or trying to sort through, right? One of the most important things for the harness to do is to get itself out of the way. Overstructuring the harness may buy you gains in the short term because you're prompting the model a lot or like trying to semi-automate something, but we want to have a simple and consistent interface that they can be trained with to improve.
We are back. We're live with Joe Gershenson and Ahmed Ibrahim, who are members of technical staff at OpenAI in the amazing OpenAI setup, working on Codex. So we have a lot to talk about Codex. They're shipping new features constantly. You know, as I was saying right before we went on, I have been a Codex user since OG Codex in 2021. So I'm a fan. So Ahmed, Joe, welcome.
Thank you. Really excited to be here.
Yeah. So where should we start? What are some of the new features about Codex that you're most excited about that have come out in the last week or two?
Oh man. You know, I actually think about this from what's going on under the hood a lot. So even more so than user-facing features, necessarily, the things that I'm always looking at are just like, how can we be more token efficient? How can we be faster? Because I think like the snappiness and responsiveness of Codex solving problems is so important to the user experience.
Yeah. Totally. So something that we heard the last guest talk about was like this whole notion of like tool calls and how like where there is still some inefficiency or like what drives the team crazy is like unnecessary tool calls. So how are you guys thinking about this?
Yeah, we like approach it from different angles. So we have like this new code mode where like the agent like write a script with the tools and like can compose it into like variables. So I think like this helped a lot in like reducing the latency and like basically making the model like more responsive. And this has helped a lot like with 5.6 solve because like it's like very helpful in like computer use or like doing like knowledge work or like even coding. It's like makes it like very interactive and like fast.
I think it's also just, if you think about what the right AGI pilled harness is, it
Yeah.
should be the model writes code and the code does everything, instead of giving the model a laundry list of tools that it should be working on or trying to sort through, right? And so I'm excited about being able to kind of allow the model to more fully express itself within the Codex harness, because I think that speaks just right to like how we're going to continue unlocking more power as the models get better.
Yeah. So on that, like in the limit, does the harness actually matter? Like, won't you just have like, you know, GPT-10 that can just kind of do everything by itself without needing to be in a harness, really?
I mean, then you still have a very simple harness. But directionally, I sort of think that this is correct, that one of the most important things for the harness to do is to get itself out of the way. And that's actually why, like, on the Codex harness team, like, we're so focused on really tightly reviewing changes to it and trying to maybe keep it slop free, because I think it's very easy to confuse models or restructure something. If you think about the bitter lesson in this context, right, which I think is kind of like what you're pointing to with does the harness even matter in the limit? You can imagine just overstructuring the harness may buy you gains in the short term because you're prompting the model a lot or like trying to semi-automate something. But really, as models continue to get better, we want to have a simple and consistent interface that they can be trained with to improve.
Yeah. So how are you thinking about long tasks? So with long tasks, you have to, you know, remember everything. You have to keep the context in certain places. How do you think about like what should be, you know, in certain files, in tool calls, what can be compacted, like how to compact context?
Yeah, I think like as Joe mentioned, you need to like design the harness to be as simple as possible and as malleable as possible. So like the agent is able to like remember its own stuff, like it's able to do many things. What another thing is like you need to help the agent recover from errors or like recover from bugs upstream
Mhm.
for long running tasks. You don't want like something running like for 1 month and then like breaking at some point while you're away from like the computer. So yeah, it's like those two parts that we focus on.
Yeah. Are there any tasks in the real world that you're seeing like specific failures or like repeated failures that are just very, very difficult to approach?
Hmm. One thing that just immediately comes to mind for me is whenever any of the tools or APIs or systems that you're talking to have intermittent failures.
Mm.
I used to build some AI voice agents using other services. This is an era before OpenAI's current models, and working with a lot of our inference providers at that startup was pretty challenging. When you think about like long-running agents that are going to use all these different things, right? We're moving towards the world of a Codex session or a thread is going to last for days, months working on like long-running tasks for you necessarily, right?
Yeah.
And so anything which is like killing the thread, you need to be able to like recover from. The agent should be like, how do I come back from this? Um, from a like technical in the weeds perspective, stuck compactions are definitely like a challenging thing to recover from. In some sense, you need to be able to figure out what happened to my context. It's now all quite bad and I have a mess.
Yeah.
And how do I like strip things out and get back to a recovered state? I think we've made some improvements there. Like we really care about what is the success rate of compactions and how does the harness fix like this, but certainly more to do.
Yeah, totally.
So have either of you used the Codex Micro?
Yes, I love it.
Really?
Genuinely, I think it's so much fun. It's tactile and satisfying. And this is very silly, I know. But first, I actually do think that voice control of Codex is awesome, right? And so just
Yeah.
having the like, I'm gonna monologue to it a little bit. I'm sure you saw Karpathy's tweet from a day or two ago about just like have a brain dump session where you just talk to the agent for a little while.
That actually, can you pull it up?
I have it pulled up. Nice long ramble session. Switch to /voice and just ramble for like 10 minutes. And then the LLMs reconstruct it. LLMs are really, really good at like just processing like unstructured data. I think
Yes.
Will DePew has a tweet on this where it's like, if you just give the model total gibberish, if you have like a keyboard in Arabic and you press the buttons in the same order, in the same keys that it would be in English, the model will understand it, even though it's total nonsense.
Yeah. Definitely.
Yeah, so I maybe to the micro question, I think it probably has encouraged me a little bit more to use uh, today's launch even and the voice interactivity because we've had this internally for a little bit, right? But having the voice interactivity there, just do the ramble session. I think the summary of the thoughts that comes back is not always like the perfect expression of things, but LLMs, like you say, are so good for this, and they're so good for making a first draft. And then I find it really useful for me to kind of take that first draft and be like, no, okay, here's what I meant. Go get to work. And I found that to be super helpful.
Yeah.
So, do you think that you could fully control Codex with everything you would want on it with just like the Codex Micro plus voice?
I haven't tried to do that. I've been thinking of it as like a fun accessory rather than the only thing, but I'm sure you could.
Yeah, I think
Honestly, true story. One of the engineers on our team got in a bike accident this week and had to get some stitches on his hand, and so he is just hard testing all the voice control features
Yeah.
of code this week. Some real forced like total dog food on that. So we'll definitely be getting some of his feedback too. But I
Yeah.
think
like I don't feel the need for like pasting logs or like pasting other stuff from like other places because like the Codex is really good now at like computer use and like Chrome use and and like multiple MCPs. So it can like pull any context and like I feel like the more context I give it via voice, like the more it's like able to do stuff. So I don't really need to write to it or like copy and paste anymore.
Yeah, I think from an accessibility viewpoint, obviously, like super helpful, like voice interaction mode is super helpful. I also think like, if you're out and about and you can like, have a device or you can have something that allows you to do like agent calls and then you can just sort of monitor everything like through voice. You can just be like walking through like a shopping mall or something. Like that is, I think, the future. Another question that I wanted to ask you guys is like, if when you get a new model, how do you guys think about making the like new model capabilities reflect in the Codex, like the coding product? Or do the models just sort of like, up level the coding product automatically?
This is, I think, in some ways really, really big because it's just the scope of our work. On the harness team, we work really, really closely with research.
Yeah.
And so we're kind of in the conversation with them from here's the problem that we're trying to solve, and just here are the things that they're going to focus on for next model releases. I think this is actually like an advantage that OpenAI and Codex have. Having the model and the harness be co-trained together and work so closely in-house really just means like we're focusing on what the problems are for developers or for folks who are like using Codex for computer use so much earlier, instead of just like you get the model and then you try to figure out how to use it or what it's good for.
Yep.
Yep.
We start before the model come, not like after it.
Yeah, totally.
Well, we're big Codex fans. So glad that you guys are working on it. Thank you so much for coming on MTS.
Thanks so much for having us.
Thanks so much, guys.
Absolutely. MTS is an ex-native live streaming news and interview show covering technology, business, politics, and culture as it happens. Catch us every weekday live on X, YouTube, or wherever you get your podcasts.